Hello everyone, good afternoon. I'm Sumudu, a software engineer at WSO2. So with 2 years in the tech game, I have been diving deep into Kubernetes. Today's talk explores smooth sailing with Helm through a quick tour of Kubernetes packaging, focusing on Helm's capabilities. So Helm is a package manager for Kubernetes. With Helm, we can install, define, and manage even the most complex applications in Kubernetes very easily. Just like Homebrew for macOS, you have Helm for Kubernetes. Think there's a Kubernetes cluster where 4 services are running. And you want to deploy an Nginx ingress controller there to manage the external traffic to these different services. So you start to implement the Nginx ingress controller by yourself from scratch, writing all the YAML manifest for cluster roles, deployments, services, and so on. And you also want to test these applications before you are going to deploy it in the cluster. So you can see how tedious task it is. But if you take the applications like Nginx ingress controller and so on, their use case is kind of same in all the scenarios. So it makes perfect sense that someone writes all the YAML manifest for applications like these ones and store in a place where others can just download and use it. Such a bundle of YAML files for a particular application is called a Helm chart. So this is the story that I have been talking up to now. The Helm developer writes all the YAML manifest and creates the Helm charts, and they upload it to the Helm repository. The Helm client, which is installed inside user's system, pulls the Helm charts and install it in the Kubernetes cluster. If you look at the directory structure of a Helm chart and the root folder, you have the chart.yaml, which includes the metadata about the chart. And all the Kubernetes manifest templates are stored inside templates folder, and the configuration values for a particular chart is stored inside values.yaml. And if there are any dependency charts, they are stored inside charts folder. So we store Helm charts in Helm repository. So it's nothing but an HTTPS server which houses an index.yaml with some packaged Helm charts. So in the repository structure in the root, we define an index.yaml, which is like a catalog or an index for all the packaged Helm charts. So you can configure your own Helm repository in GitHub, Chart Museum, Google Cloud Storage, AWS S3 bucket, and so on. Once you have configured your Helm repo, you can add it to the artifact hub, which is also known as Helm Hub, to share it with the community, unless your repo is not private. So let's go for a quick demo of creating our own Helm chart. I'm going to create a Helm chart for a simple Hello World application written in Go. So I can create a Helm chart with Helm create command, Helm create. The chart name, I'm going to give Hello World as a chart name. So it's created. If you go to this folder, you can see the Hello World chart. So Helm create command, give a chart to a Nginx application because it covers most of the scenarios. So I am going to remove all the templates files under there and will replace with my ones. So we'll delete them. And I'm going to clear the values.yaml file. OK, now I have the manifest written by me, and I'm going to copy them, and we'll move to the templates folder. OK. Anyway, I have written the deployment YAML, horizontal pod autoscaler, and service YAML. They are not templated yet. So I'm going to move the configuration values like replica count, and image name. Okay, I can copy the image name from here. Anyway, I have only added 2 values to the values.ml in this demo, but it's completely up to you what are the values you are going to add to the values.ml. So now I'm going to reference them here. With 2 curly braces, I can add values.image.name, and also the replica count, I can reference it here, .values.replica count. Okay, so we have done with templating. And also we have a chart.ml file which includes the name of the chart and the type and also the version. So this is our first version. So I will move it to 1.0.0 and app version also 1.0.0. So that's how we can easily create a Helm chart. And now we can check whether it is valid with Helm lint command. Helm lint, the path to the Helm chart. It checks for indentation errors and all things like that, and it's recommended. Now we can package our Helm chart. So Helm package, again, the name to the path to the Helm chart. Okay, we have done, and this is the packaged Helm chart. So now I can host this chart in a repo. So I am going to host this in GitHub. This is the repo I have created. And I have set up GitHub pages because Helm requires an standard HTTP server to serve as a chart repo. And this would be the chart repository URL. Now I have cloned this repository here. And I can add my package chart to the repo. And now I need an index.ml file, right? So I can add it with Helm repo index -- URL and give the URL to the Helm repo, this one. And then the path, where should it keep tonight? I give the current directory. And yeah, it's created. So now we can just push these changes to the GitHub and can use it as a Helm repository, and so when others can just add it. So when I push it, this is how it looks like, and others can just add it by adding this Helm repo. You can think that I'm a user now. I want to add this repo, Helm repo add name for the repo. I will give as repo1. You can give whatever you like, and again the URL, the repo is added, and you can see the repo with Helm repo list command. You can see repo is added, and then I can just install with the Helm install command. Helm install a name for the release. A release is nothing but a running instance of a Helm chart. When you install when you install a Helm chart, what results is a Helm release. Helm install, and then the repo1, the name of the repo, and then the chart name, hello world. Okay, so it's deployed. And now I can see the installed resources with the kubectl get command. It's stored inside default namespace. It's not still available. Okay, now it's available, and it's exposed to the outside in this port. So I can just go and look for it. Okay, so this one. Okay, so it just runs. So it's a quick demo of how we can create a Helm chart and host it. Okay, now I have talked how Helm can be used as a package manager. So think you have an application which is deployed into div, stage, and prod in 3 different environments. You don't need to have YAML manifest, deployment manifest for each environment. What you can do is you can use a common Helm chart where all the templates files can be just in one folder. And for different configuration values, which is specific for the particular environment, can be moved to different values.mls, like replica count and so on. And they can be installed separately. So, okay, Helm in CI/CD. Okay, let's have a quick look about CI/CD. So in CI, so the developer writes new code and pushes it to a source code repository. And when new code is deployed, the CI pipeline is triggered within the new image is created, and that image is pushed to a container registry. So that's basically the CI part. In the continuous delivery, we use GitOps principles. So GitOps is nothing but a framework to automate the deployment of applications. So one of the principles in GitOps is X as code, where X refers to the infrastructure, network, policies, and so on. So we can use Helm charts to define this infrastructure configurations and so on. And we can store them inside GitOps repository. Then the CD tools comes to the picture, where that CD tools like FluxCD. So FluxCD is a GitOps continuous delivery tool for Kubernetes, just like Argo CD. They watch the GitOps repositories continuously and apply all the changes to Kubernetes cluster simultaneously. So using Helm charts for XaaS code have numerous benefits, like it's easy to versioning and also increases reusability and scalability. Other than that, we can keep the consistency across all the environments. Yeah, these are some of them. So Flux and Helm in continuous delivery. So we have Flux installed Kubernetes cluster, and we have the remote GitOps repository. Now we want to configure Flux to connect with the remote repo. We are doing that by defining custom resource definition files. So one is we can define Helm repository CRD, where we specify the URL to the remote repo, and also the interval. That means the frequency, how it should look the GitOps repo. And then also we can define the Helm release for the CRD for Helm release, where we have embedded the Helm chart details like name, which repo is it in, and again the interval and so on. After applying the CRDs to the cluster, now Flux is configured to watch the GitOps repositories. So when you install Flux, there are certain components deployed like source controller, Helm controller, notification controller, and some of them. There are much more. Anyway, what happens is the source controller continuously watching this remote repo, and when there is new changes are happening to the charts, Helm charts, it notifies the Helm controller. And Helm controller is responsible for applying all the things to the Kubernetes cluster when there's new things. So I have used Helm a lot in my real life. This is one of the scenarios. At WSO2, I'm working in a product called Choreo, which is an internal developer platform. So we let our users to bring their own Kubernetes cluster and connect with our control plane to work with. So what they bring is not just a Kubernetes cluster. They will have some things like container registry and so on. And we need to configure the Choreo private data plane to communicate with the Choreo control plane. How we are doing it is installing components like agent, Flux, Nginx, ingress control, and there are a lot more that I haven't put it here. So we are not going to install them by one. What we have done is we have packaged one Helm chart with adding all these components, and we are configuring a private data plane with just one Helm install command. So that's come to an end in our talk. I have basically looking at the motivation behind Helm, the Helm charts and Helm repositories, how to create a Helm chart and how to put it, how to host it, and Helm as a templating engine. Also the usage of Helm in CI/CD and how Flux and Helm works together for continuous delivery. So if you are interested in this topic, you can have a quick look at this additional resources there. And happy Helming. Thank you. And yeah, you can reach out to me anytime if you have any questions. Yeah, thank you.